Okay, so we're going to be looking at how to draw histograms and frequency polygons in this video. What you see here is a graphical set of axes that I've already created to go with the data that you saw in the opening slide. On what's typically referred to as the y-axis, I'm going to be putting frequencies, and the x-axis, I'm going to have the salaries in thousands of dollars. So on histograms and frequency polygons, 99% of the time your vertical axis is going to be frequency. Now these numbers you see down here are not any of the numbers that were actually in the frequency distribution. In fact, if you go back to refer to that, if you wrote it down, the first class was 26 to 30, and we're told that 3 people were in that class. But on my graph here, you don't see 26 to 30 anywhere, and that's because on histograms and frequency polygons, you do not use the entire class. You actually use the class mark or the class midpoint to indicate that particular region on the graph. So this 28 is the midpoint of this first class. And remember, the way that you calculate midpoint is you take the 26 and 30, add them together, and divide by 2. So you get 56 over 2, or 28, and so that's the midpoint. And so what I've done is found the midpoint for each of the other classes. There were 7 total classes, and these are their corresponding midpoints. What ends up happening, though, once you found a couple, you can see that the midpoints will always skip by the same amount. In this case, it's 5. And the amount that the midpoints skip by is also the width of each class. So the class width in each case is 5. There are 5 values that would fit into that particular case. Okay, so now I want to start by drawing the histogram. There were 3 people who had salaries in the range from $26,000 to $30,000. So the 28, remember, marks that. My increments here are just 1, so I'm going to go up and just put a dot where it was 3 high. Okay, I'll come back to drawing bars in a minute. The next class was 31 to 35. The midpoint would be 33, and there were 5 people there. The third class had 8 people in it, and then 10 people, 6, 3, and 2. Okay, and so if we're going to draw a histogram, the way that's done is that we put a vertical bar that goes up as high as the value of the frequency for that particular class. And there's no space left between bars. So when I go to the next class, the left-hand side of the bar for the second class is also the same thing as the right-hand side of the bar for the first class. We just continue drawing the bars here. Filling in. And there you have histogram. Now the one thing that this graph is missing is a title, because somebody who looks at this would have no idea what's going on. So you put a title at the top, something along the lines of salaries in $1,000 for employees at ABC Corporation. And that would be the example of the histogram. The frequency polygon is incredibly easy to draw, especially if you've already drawn a histogram. So these dots that I've put up there, we're just going to connect with straight line segments. So dot to dot. It's almost like a connect the dots game. Now, there's one more thing that needs to be done in order to make the frequency polygon complete, and that is to add a class on both the lower edge of the data and the upper edge of the data. If you remember from geometry, what a polygon actually is it's an enclosed geometric figure where all the sides are straight line segments. Well, currently, I don't have an enclosed figure because it starts here and goes to here. If I'm going to end the figure, I need to bring it back down to the axis over here. So I'm going to create two more classes. This would be the class where 23 is the midpoint, and this is the class where 63 is the midpoint. Nobody's in either one of those classes, so the line will go back down to the axis, and now you have a closed figure where the axis is one side and then the straight line segments make up the other sides. And so we could leave everything the same on here. The labels for the axes still mean the same thing. The title of the graph is still the same thing. It just depends on which one you want. The histogram is the vertical bar graph where all the bars touch, and the frequency polygon is basically a line graph that goes back down to the axis. Okay, so now you've received some data regarding salaries again at ABC Corporation, and what I'd like to do is to answer those questions you saw on the previous slide. First of all, what is the most common salary? Part A to the problem. The most common salary is the mode. Mode is always most common, so we just read off from the data we had. That figure was $40,000. Question B asks, what salary did half of the employees' salaries surpass? Now, if we're going to find the value at which half surpass, that's the value that's exactly in the middle, if we were to line them all up from smallest salary to largest salary. So that means we're looking for the median. That's the one that takes into account the order. And so the median salary was $41,000 from your chart. Question C says, about what percent of employees' salaries surpassed $50,500? Now, if you go back and look again at the chart of the data, 50,500 was the third quartile. Quartiles split the data into 4 equal pieces. The third quartile splits the third piece from the fourth piece. So 75% of the data is smaller than the third quartile, or 3/4 of the data. So basically that question is asking for the third quartile, and that's going to correspond to, since we want to know what percent of the employees' salaries surpassed that value, if there were 3/4 below it or 75% below it, then we have 1/4 or 25% above that value. Question D says, about what percent of employees' salaries were less than $34,500? Well, $34,500 was the first quartile value, and that means that there will be 25% below that. Just as if there was 25% above the third quartile, there's going to be 25% below the first quartile. Question E, about what percent of employees' salaries surpassed $46,000? So $46,000, if you look again at the data, corresponds to the 67th percentile. So if I want to know how much surpassed that or how much was above, if you're at the 67th percentile, then 67% of the data is below that value, which then means that 33% must be above. Okay, last question, question F, asks, if the company has 37 employees, what is the total weekly salary of all employees? And at first you feel like you don't have enough information to answer this, but really the key to it is the mean value. Because if you remember the formula for mean, x bar is the sum of the x's divided by n, where the sum of the x's, in this case each x value would be a salary, so the sum of the salaries divided by n, which would be the number of salaries. Well, we know x bar, the mean salary, and we know n, the number of employees, so we can find the sum of the salaries, or the total payroll. So plugging the values in, the mean salary was $42,000, and the number of salaries was 37. So very simple algebra here. If I want to know what the sum of the salaries was, multiply both sides by 37, and I get that the sum of the x's equals 37 times 42,000, which ends up being $1,554,000.